Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to start with the discussion of AXI ordering model. Now, in AXI, multiple read or write transactions can be active at the same time. Now, what do I mean by this? So in AXI, we have out of order. So what do you mean by out of order? So basically the response data or write acknowledgements can written in a different order than the request were issued. So this is allowed as long as our ID values are used correctly. So why do we need this AXI out of ordering? Because AXI was designed for high performance CPUs, GPUs and DMA engines where some memory regions respond faster and some memory regions take longer. For example, DDR. And some may access can be serviced immediately, and out of order responses help improve the throughput and pipeline utilization. Now, what do I mean this? Let's say suppose this is my processor and this is, let's say, one component like DDR, okay, and let's say this is some memory region, and we have three components like this, and our processor is being connected with this particular three processors, right? Let's say this is some DMA interface we are going to have, right? Now this processor, let's say, has issued a transaction, first transaction request to our DDR, second to the second component, and third to the third component. So like this, the order was 1, 2, 3, but the responses we can get in any order using the out of order transactions. So the processor can take responses from 3, 2 and 1. There is no order at all. That is nothing but our out of order transactions. Now let's see one example. Let us say if we are going to have one DDR memory, some L1 cache, okay. Let's say this is our DDR memory and some cache memory we are going to have, and this is our processor which is being communicating with this DDR and this cache. Now let's say this DDR memory is little bit slow and cache is faster, okay. Now CPU is basically asking the data from DDR, which is a slow memory, okay. The processor is basically request the DDR to send the data, okay, and the processor next, it has mentioned our cache for for sending the data, okay. Now if these transactions use different IDs, then the cache can return first. Now the processor has asked the DDR to send the data first, and next the processor has asked the cache to send the data. This is the order. First, the processor should expect the data from the DDR, and second, it should expect the data from the cache. But if we are using something known as out of order completion, then this transaction will complete out of order. What do you mean? That means the cache can send the data before the DDR sends the data, and after the cache has sent the data to the processor, the DDR also can send the data to the processor. So this is nothing but my out of order completion, and this is a special feature which we have in our AXI protocol and we don't have in this AHB protocol, okay. Basically in AHB protocol, whatever the component you have requested, that particular transaction should be completed and next only the another transaction should start. But in AXI protocol, before completing one transaction, the processor can start another transaction and complete that particular transaction, and the other transaction which was initiated first, that can complete later, okay. That is nothing but my out of order completion. Now for achieving this out of order completion, we are going to use something known as ID. We are going to use something known as ID. Using this ID, we are going to perform out of order transactions. Now, what do you mean by this ID? So, we have different IDs for different channels. For read address channel, we have something known as ARID, and for write address channel, we have something known as AWID, and for read and for read data channel we have something known as read ID, and for write data channel we have something known as write ID, and for response channel we have something known as BID. So these are the ID fields which we are going to have for any transactions in AXI. Now the transactions with different IDs can complete in any order. This is the rule which we are going to have, but the transactions with the same ID must complete in the same order. This is the rule which we are going to follow. That means, let's say this is my processor and this is my component 1, and this is my component 2. Okay. Now let's say if my processor is communicating with this component 1 and component 2. Now let's say the processor is connected to this component 1 and component 2 using 5 channels. So let's say if my processor issues a address to the channel 1 and to the component 1, and the processor issues the address for the component 2. Now, so let's say this component C1 is little bit slower than our component C2. Then our processor has sent the first request to our component 1. Next it has sent to our component 2. Now, before component 1 sends the data to the processor, the component 2 can send the data. There is no order at all. That is nothing but my out of order. And the data channels for the component 1 and component 2 have different IDs, so that I can complete the transaction in any order. There is no order at all. So this is a typical example for understanding of my out of order transaction. Now these are some of the fields which we need to know for understanding this out of order. So I have something known as AWID. So this is the ID tag for the write address group of signals, and I have WID. This is the ID tag for the write transaction, and along with the write data, the master transfers a WID to match the AWID of the corresponding address. So along with the write data, the master is also going to transfer a WID signal, and it is going to match with the AWID of the corresponding address. And I have something known as BID. So this is the ID tag for the write response. So the slave transfers a BID to match with the AWID and WID. And I have something known as ARID. So the ID tag for the read address group of signals, and RID, this is the ID tag for the read transactions. Now let us see some of the rules which we have in the case of ordering. So the transactions from different master have no ordering restrictions. That means they can complete in any order. What do I mean by this is, let's say if I have different masters like this and different slaves like this, 3 masters and 3 slaves. This is master M1, M2 and M3, and this is my slave S1, S2 and S3. Now, so these different masters and different slaves are basically connected with the help of my interconnect. Now, using this interconnect, my master and slave are going to communicate with each other. Now, let's say if the master sends a transaction T1, first it is only going to send. Next, the master 2 is going to send the transaction T2 request, and the master 3 is sending the transaction T3. Now, it is the rule for the interconnect to select this particular T1 transaction or T2 transaction or T3 transaction, and there is no ordering at all restriction. There is no ordering restriction. So the interconnect first issue this T2 to the slave 2, and next it can send this transaction T3 to our slave 3, and next it can send our transaction T1 to the slave 1. So there is no order restriction. Different masters can complete the transaction in any order which we want. That is nothing but my out of order transactions. Now, so the transactions from the same master but different ID values have no ordering restrictions. They can complete in any order. What do I mean by this? Let's say I have a single master and a single slave like this, but I have 5 channels. Okay, 1, 2, 3, 4 and 5. Okay, now the very first channel which I am going to have is ARID, or my read address channel, right? And another channel I am going to have is RID, that means read data channel, read data. Next channel I am going to have is AWID, that means write address channel. And next channel I am going to have is WID, that means this is write address channel, and next is write data channel, and next is BID, that means response channel, right? So these are the 5 independent channels I am going to have, where my master and slave are going to have, right? Now let's say if the master wants to read the data, then First of all, it is going to provide the read address using the read address channel. Okay, so I will write it down here. If my, first of all, let's say if my master wants to perform a read operation, if my master wants to perform a read operation, then what it is going to do, it is going to first of all send a read address. Okay, using the using the read address channel, it is going to send. Okay, it is going to send basically AR address. It is going to send this address, right? This we already know. Now next, the slave is going to send the data. The slave is going to send the data using the R data channel. It is going to send the data. This we already know, right? Let's say, suppose, let me erase this. My master, before reading the data, let's say the slave is little bit slower. So the master, before reading the data from the slave, it can also issue a write address to our slave. It can also issue a write transaction or write information to my slave. So let's say the master, the slave is little bit slower to send the data to the master. So what master can do is, it can also provide the write address information. That is, if my master wants to write any data, it can also provide the write information to my slave using the write address channel. It can provide the address information to my slave. This the master can do in your out of order transaction, because the rule is different. If the master is using different IDs, there is no order at all, right? Now let's say if my if my master wants to write the data before the slave sends the data to the master, that is, before master performs the read operation, the master can perform the write operation. That means master can perform the write operation using the write data channel. It is going to perform the write operation using the write data channel. So it is also going to send the W data to my slave. You can see here, first the master has issued read address. That is, it wants to read some data, so it has issued a read address using the read address information, read address channel. Next, the master wants to perform a write operation. So what it has done, without completing the read transaction, it has issued another transaction, that is a write transaction, and it is providing the write address using the write address channel. Next, master haven't completed the read operation at all, but it has started the write operation. What it is doing, it is writing the data using the write data channel. Next, before reading only, the master can also get the response using the master can get the response using the read. The master can get the response using the response channel. Okay, the master can get the response, B response. You can see still there is a pending transaction, that is read transaction haven't happened yet, but before happening that, these are all transactions has completed, and finally the master can read the data. If the master wants to read the data, it can read the data. There is no restriction on the order. But in the AHB protocol, we need to first complete the transaction which has started. But in AXI protocol, there is no that particular such restriction, and your master can perform any transaction in any order it wants to do. Now let's take one more example. Let's say this is my master and this is my slave. Okay, this is my read address channel, read data channel, write address channel, write data channel, response channel. Okay, sorry, the read data channel, it will be in opposite direction. Now let's say if my master has issued a read operation by providing a read address on the AR address channel, it has provided an address information on the read address channel. That is, it has started a transaction. Let us say it as T1. Now let's say if my master wants to perform another read transaction, it is providing another read transaction. Let's say read address, it is providing another transaction T2. The T2 transaction is also another transaction where it is providing another read address to the slave. Now, first of all, the slave is not allowed to complete, the slave is not allowed to start T2 transaction until and unless T1 transaction has been completed. What do I mean by this is the slave should complete the first transaction. That means it should send the data corresponding to the T1 transaction. Data corresponding to T1 transaction it should send. That means it should complete the T1 transaction. Then only the slave is allowed to complete the or start the T2 transaction, because here for the read address T1 transaction we are going to have same AR ID. Let's say AR ID is equal to 0 and here AR ID is equal to 1. Since the master is using the same channel, both the transactions will have the same ID. Now if you are having the same IDs, then the master and slave should complete in the same order which they are issuing. But if the master wants to perform a write operation, that means if it is sending a write address, then what is the ID signal which is corresponding to that? That is nothing but WID. So since the ID is different, so the master can perform the write operation before completing this read transactions. That is the example which we have seen previously. So this is nothing but my out of order transaction and some of the rules which are governing my out of order transaction. So it is what written here. So the transactions from the same master but different ID values. This is what I am stressing about. Having no order restrictions, they can complete in any order. But the data for a sequence of write transactions with the same AWID value must complete in the same order that the master issued in the addresses in. Okay. And the data for a sequence of read transactions with the same ARID value must be written in the order that when the read with the same ARID or from the same slave, then the slave must ensure that the read data returns in the same order that the addresses are received. This is the example which I have taken previously. And when the read with the same ARID are from different slaves, the interconnect must ensure that the read data written that the read data must written in the same order that the master issued the addresses in. This is the same example I have taken and I have explained you, and this is the theory part which it has written. So there are no ordering restrictions between the read and write transactions in the same AWID and ARID. This is the very first example I have taken. There is no restriction between the read and write transactions. And if a master requires an ordering restriction, then it must ensure that first transaction is fully completed before the second transaction is issued. So that's about out of ordering transactions, where we have learned how this out of order is going to happen and on what mechanism this out of ordering is basically happen. Yes, so that's all about this particular session. If you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.